Good morning, everyone. Welcome to the STEM Digital School. This is grade 6 Natural Sciences and Technology. All right, so guys, we will be continuing from energy and change, and we are looking at electrical conductors and insulators. Okay, so this is term three's work. Right, so hello to everyone. I see you guys have greeted in the group chat. Guys, just a few ground rules. Please do not switch on your cameras throughout the lesson. Please do not switch on the cameras throughout the lesson. You may raise your hand, right, to ask a question or to give an answer, or you can use the group chat. Guys, the group chat only chat with regarding the lesson, please. All right. Can you please use the group chat for chats regarding the lesson? Okay, so anything outside, can we, just leave it outside. All right. So yesterday we started off with electrical conductors and insulators, and we also wrapped up electrical circuits. Okay. So I want to know from you guys, because you were so busy in the group chat yesterday, what did you learn in class? Can you raise your hand and tell me what you learned? Tell me about the notes you made. Yeah, or you can use the group chat to send me like a summary of what you learned yesterday in class. Let's go. Also, if we do have anyone who is new, we are on term 3. Yeah? It's term 3, energy and change, and we are looking at electrical conductors as well as insulators. Okay, guys, what did you learn in class yesterday? Okay, yeah, what about insulators and conductors? Actually, guys, raise your hands. I want to talk to you. Raise your hands. I want to hear you guys say these things so that I can ask you questions and you'll be able to answer immediately. No volunteers. Wow, okay. Okay. Yeah.
Hey, ma'am.
How are you?
I'm fine, and how are you?
I'm good, thanks. So what did you learn about insulators and conductors yesterday? What about them?
I learned that electrical conductors are materials that conduct electricity, and materials that do not conduct electricity are insulators.
Okay, perfect. So give me an example of an electrical conductor that you learned about yesterday.
An electrical conductor is water, like we were talking about yesterday.
All right, and we said that not pure water.
No, salt water.
Salt water. All right, and then what is the metal that they use in South Africa to move electricity? Guys, make sure that your videos are off. Someone's video is on. Rams,
Aluminium.
switch off your video. Sorry about that, yeah. Okay, cool. Sorry, come again.
Yes, the metal that's used is aluminium.
Oh, yeah. Okay, so remember we said aluminium, né? What did we say about aluminium again? I think we said that it doesn't really conduct electricity, but it's used for weight. Okay.
Yes, ma'am.
To increase weight, and the metal that is readily used to move electricity is copper.
Okay, ma'am.
All right, awesome. Thank you very much, Kia.
Thank you, ma'am.
Cool. Right. I need someone else. What did you guys learn yesterday? Okay, Tugelo says, ma'am, I learned that there are wires which conduct energy. I think you were continuing, for example. Can you raise your hand, Tugelo, and we'll talk. Come ahead. How?
Ma'am, I also learned the same thing here. I learned that electrical conductors are materials that electricity can go through, and insulators are materials through which an electric current cannot go through.
Okay, so that's all you learned about, like you only learned about conductors and insulators.
Yes, ma'am.
Why are you sounding so shy and unsure? Okay. Remember we're wrapping up electric circuits. What did you learn there?
Ma'am,
We were wrapping up the section of electric circuits. Remember, we're not done with electric circuits. So what did you learn yesterday on the part where we were looking at electric circuits? How? Come on, don't mute yourself. Let's talk.
ma'am, I learned that electric circuits are systems for transferring energy from one place to another. And I also learned there that electricity is also an energy.
Okay, thank you very much, Kamohelo. Awesome. Okay, beautiful. Okay, Kia, I need new hands. Everyone who was talking yesterday needs to answer me. Josie Lee, where are you? What did you learn yesterday? Tukello, you haven't finished your sentence in the group chat. Mokona, what did you learn yesterday? Talk to me, guys. Sive, you were also in class yesterday. What did you learn? Talia? You can raise your hand, Tukello, then we can talk. Okay, Kia, let me hear what you have to say while they are still typing or contemplating on
ma'am.
raising their hands. Yes?
Ma'am, I wanted to answer the question that you asked Kamo.
Okay. Answer the question. Kana, what was the question that I asked, Kamo?
Ma'am, you asked what did we close we learn when we closed up about electric circuits.
Oh, okay. Yes, you can go for it.
Yes, ma'am, you asked learn when we closed up about electric circuits. That there was one picture where the switch was open and the one where it was closed, and the one where it was open, the electricity wouldn't flow, so we called it a closed circuit, and then the one with the closed switch is a open circuit.
Oh, you're mixing them up again. Remember, the one that's open is a open circuit, ne?
Oh
The
no,
one that's closed is a closed
open
circuit.
circuit. The one
Yes.
closed is a closed circuit, ma'am.
Yes.
Sorry. And the
Wonderful.
one that's
Yeah.
open, the electricity won't be able to flow, and then the one that's closed, the electricity will be able to flow.
All right. Beautiful. Thank you very much, Gia.
Thank you, ma'am.
Awesome. Look at your hand. Oh, okay. There we go. I thought you had put your hand down. Talk to me, Tukello. What did you learn
Ma'am, yesterday I learned that most of our body can conduct electricity as well as salt water.
All right.
Yes, and
oh, okay. Yes.
yes, ma'am, and I learned which wires can conduct electricity and which cannot, and which different types of electricity can a wire conduct, and the different types of sources of energy like copper. It's easy for electricity to flow through because you said that it's easy to bend.
Oh, yes, yes. Beautiful. Thank you
Yes,
very
ma'am.
much, Tukello. Oh, do you have more?
You're
You have more to
welcome,
share?
ma'am.
You have more to share?
No, ma'am. Ma'am, when I'm still thinking about more, then I'll give you more, ma'am.
Okay, thank you very much, Tukello. All right, so Tukello, Kamohelo, and Kia just shared with us what they learned. I see in the group, Talia says, I learned that conductors are materials that carry electricity. All right. And then Talia also continues to say metal materials such as copper, iron, and aluminium are good conductors. All right. Thank you very much, Talia, for that addition. Okay. So guys, please remember, let's focus on in class. All right, let's focus on the work that we are doing so that we can learn. All right. Thank you very much for that, Kia. Thank you. Should continue doing that. So these are some of the slides that we covered yesterday with regards to conductors, right? We said that a conductor is a material that allows electricity to flow through it, and an insulator does not allow electricity to flow through it, all right? And then we spoke about good electrical conductors. This is where we mentioned the silver, the gold, the aluminium, where we said that in as much as it is a metal, it's not a very good conductor. Yes, it does conduct electricity, but it's not a very good conductor. And our bodies are also good conductors of electricity because they have a mixture, or rather, they have other elements, if I can call them that, or if we can call them, like, you know, our bodies have salt, right? So, and you know that salt water conducts electricity, right? So our bodies do not have pure water, right? So it's a mixture, and that is why our body can conduct electricity. Okay. Then we said that copper is a very good conductor, and it is used in most conducting wires in electric circuits. And we also said that it is inexpensive, it cannot bend, or rather it can bend, sorry, without breaking. And that is the other reasons why it is used in a lot of electrical installations. Okay. All right, just hold on, guys. Whoa, all right, guys, I will come back to this slide. I just wanted to, I think I swapped the slides a bit. All right, so this is an activity, okay? Wrapping up what we also learned yesterday about electric circuits. Okay, so it reads, match the components on the diagram with the words appearing on the left. So there will be words appearing and you guys will need to tell me whether those words match with A, B, C, D, or E. Okay. So Talia says, ma'am, is today's topic electric conductors? It's electric conductors and insulators. That's today's topic. And remember, yesterday we had already covered conductors. So today we'll be looking at insulators. Okay. But before we get into that, let's do this quick activity. So the first word here we have is the positive side of the cell. The positive side of the cell. Is it A, B, C, D, or E? Okay, Tugelo, I see your hand. Hey, boy, it went down again. All right. There we go, Tugelo. You guys can also answer in the group.
Ma'am, ma'am, I think the positive side of the cell is C.
It's C. Okay, let's see if it's C, or rather, let's wait for other people to answer. Guys, the positive side of the cell, is it A, B, C, or D? Tugelo says it's C. What do you guys say? Ia says it's C. Adeline says it's C. Kamohelo also says it's C. All right. Okay, let's see. Rams.
Hello, ma'am.
Hi, how are you?
I'm fine, and you?
I'm well.
Ma'am, the positive side is D.
All right, thank you, Rams. So Rams says is D, and most of you, I see that you guys are sticking with C. All right, so let's see what, let's see. Adeline changed. Adeline says it's A. Okay, let's see. C with the S, no? All right, so the positive side is D. Guys, remember, we said the positive end of the cell is the longest strand, okay? So in the cell components, the longest strand indicates the positive side of the cell or of the battery, all right? The longest strand is always the positive side. Okay, and remember we said that current, electric current flows from the positive to the negative, okay? Right, let's see what we have next. The negative side of the cell. The negative side of the cell. All right, here says it's C. Okay, it's obvious. All right, Adeline says it's A. Okay, Talia runs. They say it is C. Okay, let's see. Come on, hello. Come on. Yo, we can't hear you. I can see you talking, but we can't hear you. All right, I'm gonna just type in the group now. All right. So yes, guys, it is C. Guys, this indicates, this is a symbol for a cell or a battery. Okay, so this whole structure here, this indicates a battery or a cell. Okay, don't forget that. Remember, we did cover cell components and their symbols. So that was also something that you guys needed to learn from yesterday's lesson. Okay. Then a switch, is it indicated by A, B, or E? The switch. Okay, I see here saying B. Okay, take a look.
Ma'am, the switch is B.
Okay, and the way the switch is positioned, will electric current flow or not?
It will not flow.
All right, beautiful. Thank you very much, Tukelo.
You're welcome, ma'am.
Okay, so most of us got it. See, we all saying it's B. Okay, so yes, indeed, it is B. And then the light bulb, is it A or E? Is the light bulb A or E? Yeah.
You ma'am, the light bulb is A.
All right, beautiful. So in this case, if the light bulb is A, will it be on or off?
It will be off because the switch is open and not closed.
Okay, beautiful. Thank you very much. Okay, let's hear Adeline. Adeline. Okay, Adeline, there is no, yeah, there is no sound coming through from you, but I see you responded in the group. You say A, okay. All right, so let's see the light bulb. It is indeed A, and the light bulb in this circuit diagram would be off, okay, because the switch is off. And if the switch is off or if the switch is open, then we have a break in current. Current does not flow, okay. And this one is the obvious one, obvious, it's E, okay. So I see, Bigelo, your hand is up. I think you wanted to give an answer.
Ma'am, E is the wire.
Okay, so how many wires do we have in this electrical circuit?
We have 3 wires, ma'am.
All right, beautiful. Thank you very much, Tekella.
You're welcome, ma'am.
Awesome. Okay, beautiful, guys. So we have 3 wires in this particular circuit. Okay, so I'm just going to take us back to this slide here because I just mixed them up. All right, and then we're going to move on. So insulators, that is what we are looking at today. That is the topic for today, which is insulators. So remember, we had already defined an insulator, saying that it's a material that does not allow electrical charge to flow through it. And remember, again, guys, we said that some textbooks speak of electrical current, and other textbooks speak of electrical charge, others speak of electricity. Okay, so it is the same thing. Okay, so they're just using the words interchangeably. Okay, and then insulators are used because electricity can be very dangerous. All right, and examples of of insulators is your plastic and rubber. All right, and here we have a picture where insulating material has been used, and we have our copper wire, which is within the insulators. All right, just as indicated here at this bottom picture. Okay. All right. Yo, sorry guys. Can I move on? can I move on? Just indicate for me. Or do you guys need some time to jot down this information? Okay. I see a yes, yes. Okay, all right, cool. Right, so common insulators that we find, we have your rubber, okay, we have mica, we have wax of paraffin, porcelain, bakelite, we have plastics, glass, fiberglass, dry wood, as well as air. Okay, so these substances or materials do not allow electricity to flow. Okay, so these are actually good insulators. And here we have examples. This is the bakelite. It's the material that they make the buttons out of, right? So buttons of your shirt are most probably made out of bakelite. Then we have the mica, okay? And this is our porcelain, which is usually used in making china, okay? And then we have our rubber, and we have our fiberglass, okay? So I see a hand.
Ma'am, I also wanted to tell you that a plastic ruler does not allow electricity to flow properly.
All right, so plastic ruler does not allow electricity to flow, meaning that it is an insulator. Thank you very
Yes.
much for sharing, Tukelo. Okay, Adeline, I see your hand is up. Adeline? Okay, that was probably a mistake. Okay, Nokia, not what you wrote there, and Talia, also not what you wrote there. This is what I'm talking about. Okay, this is what I'm talking about. Yeah, so you can just go on Google, né, and then type it in, and then you will see what appears. Just go to images and you will see like what appears, the objects that appear. All right. Don't forget the material. Say China material. Okay. All right. So insulation and dangers of worn insulation. Adeline, I'm not sure if you have a question, but can you please type it in the group, because I've been trying to unmute you and there is no sound coming from you. Okay, just lower your hand down. All right, so let's look at insulation and dangers of worn material. Right, so when we speak about insulation, remember we already covered what an insulator is, and that is a material that does not allow electricity to flow through it. So insulation is basically using an insulator. Okay, so basically we are covering up a conductor of electricity with an insulator. So that process is called insulation. All right, Adeline? So insulation is the process where we cover up the conductor with the insulator. Okay. Because remember in the first slide, we said that electricity is very dangerous, right? Electricity is very dangerous. Okay. So the electric wires of all main appliances are coated with an outer layer of plastic, right? And electric wires of all main appliances are coated with an outer layer of plastic. So an example is your charger, guys, your phone charger, your laptop charger. I'm sure you guys have not seen wires just standing around like copper just roaming around, or silver roaming around, right? Every electrical wire that we use in our homes is always covered with plastic, an outer layer of plastic. Okay, so being it your kettle, being it the plug, or rather the wire of the microwave, of the stove, of your mouse, anything, everything and anything that conducts electricity should always be covered with a layer of plastic or another insulating material. All right. So inside the plastic layer, there are 3 copper wires that are also coated with their own plastic layer. But guys, this is not always the case. So this second bullet is mainly talking about your large appliances. Okay. So these protective layers are known as insulation, and then the inner layers of insulation are usually colored, and this is just to differentiate between those that carry electricity to the appliance and the earth wire, which keeps electricity safe. Okay, so I'm going to give you guys just about 2 minutes to write this down, and then we can continue. So if any of you guys who are done want to share anything with us, or maybe read out of your textbook for us, then you can do so in this time. All right. But once everyone is done, just indicate for me so we can move on. Okay, so once everyone is done, just use the yes button and just type done in the group chat so we can move on. Right? Okay, let's see you the no. Okay, so Adeline is asking a question. What is the danger of electricity? So I'd like to pose it out to you guys. Can one of you guys answer why electricity is dangerous? Okay, so I see here is already gave an answer, says electricity will choke you. That's why it's dangerous, sorry. Dangerous. So it will choke you. Shock you. Yes, it will shock you. Right, so Adeline, I hope you are answered. All right, so then we get into like the extreme case, it might also kill you, Kia says, which is very true. So the shock is it's very dangerous for your body, you know. So yes, indeed, it might kill you. All right, guys, can we move on? Are we done? Okay. I need responses, guys. Are we done? See there? I see you. Okay, cool, guys. So I am going to move on, right? So guys, when the installation, so this is just an example of as to why we shouldn't be using wires or appliances which have a broken insulation, okay? So this is just a continuation of the previous slide, right? So when the insulation on an appliance is broken or damaged, it will give you an electric shock if you touch it. Okay, so this is the same thing that Gia mentioned in the group. If you touch a damaged electrical appliance, right, or rather an appliance whose insulation is damaged, then you might get an electric shock, right? So never touch electric circuits or electric cables or plugs with bad insulation unless you are absolutely sure the power is off. And my question to you guys is, why should the power be off before you touch that bad insulation? Why should the power be off before you touch that bad insulation? Okay, Tukello?
Because, ma'am, it'll either shock you or it'll give you like it will send electricity through your body.
Okay, so that's why the power should be off. Okay, then
Yes,
what
ma'am.
happens? What happens when the power is off?
Then nothing will happen to you. You'll just be fine, ma'am. No electricity will shock you.
Okay, that is my question. Why won't the electricity shock you?
Because the switch that let's say electricity flow is closed.
All right, beautiful. So the electricity flow is cut or is closed. Thank you very much, Tukello.
You're welcome, ma'am.
Awesome. Okay. Yeah, let me hear what you wanted to say.
Thank you, ma'am. Why I say when it's, ma'am, may you please repeat the question? I forgot.
Okay, so we read the second bullet, saying that never touch electric
Yes, ma'am.
circuits or electric cables or plugs with bad insulation unless you are absolutely sure the power is off. And my question is, why should the power be off?
Oh yes, ma'am. Why should the power be off? Is that our body can take electricity. It's not used to electricity, and the power should be off so that when you touch it, you don't get choked or the electricity flows into your body, and then it
Okay.
might go into your, it might target your heart, and then it will make your heart. Oh yes, ma'am, stop, and then you die.
Okay, beautiful, beautiful, beautiful. I love that. So my other question is, if when the power is off, why won't there be any electricity flow?
Oh yeah, is it when the power is on, the electricity will be flowing, and then if you switch off the power, the energy will be cut. It won't, no energy will be able to flow because the circuit will be open.
Beautiful. Thank you very much, Gia. Beautiful, beautiful.
Thank you, ma'am.
Awesome. Okay, let us move on. Okay, I see in the group, Adeline says, so you don't shock yourself. Okay, so it won't shock you when the electricity or the power is off. Yes, that is correct. Okay, so our next bullet says, if an appliance smokes or sparks, or if you feel a tingle or shock when working with the appliance, do not use it. Okay, so if you see smoke appearing or sparks appearing on a particular electric appliance, please do not use it. All right, do not use it. Stop with its usage. And then what you should do is you should fix the insulation before you switch on the appliance again. All right, so broken insulation might also cause power trips. All right, and you find that the power, or rather the electricity at home, it all falls, or the circuit breaks. Okay, so using appliances with broken insulation is a no. Okay, so here we have an example of worn insulation, which is very dangerous. And as you guys can see here on the picture, that the material that was used on the outer part is your fiberglass, right? And then inside it is the plastic. Okay, so this wire is highly insulated, but unfortunately the insulation has worn out. So we cannot use, or rather we should not use appliances which have worn insulation, right? Okay, using insulators. So this is another example where insulators are used. So the electric cables that carry electricity across South Africa are held up by metal pylons. Okay, so there are glass or ceramic insulators that are used to keep the wires apart from each other and fastened to the frame of a pylon. Okay, then if the electric cable was fastened directly onto the pylon, the electric current will flow into the pylon, and this would be a very dangerous situation. So when you're talking about the pylon, it's these, these ceramic or glass insulators. I'm sure you guys have seen them, if or while traveling on the roads. So these are the ceramic discs that insulate the cable from the pylon. All right. So the pylon is this long structure here, and these ceramic discs just basically insulate the electricity that's flowing on these cables so that it doesn't enter the pylon. All right. Okay. Then electricians, oh, sorry guys. I'll just give you guys some time there. If you are done, just indicate for me, okay? If I can move on, say yes, done. Just give me an indication. All right. Okay, beautiful. Okay, Tanya, I'll give you a minute, and then we will move on. Okay, so Tadia, just indicate for me when you're done, all right? Guys, remember today you need to download your natural sciences and technology test. All right, you need to download your natural sciences and technology test today and fill it in. Okay, please do not cheat and have a maximum of an hour allocated, right? So you guys can only have an hour to fill up the question paper. Then when you are done, you email it to me, all right? You email me your answers. So you can either type it out, print it out, then fill it in, or you can just do it on the computer, fill in your answers on the computer, or you can even just write the answers in your exercise books, take pictures and send me the email, all right? Okay, so my email, I will show it just before class ends. Okay, electricians are people who work with electricity. So if one day you are aspiring to work with electricity, then this is your section. Would most likely call you an electrician. Right. So electricians wear electrical safety gloves and boots with thick rubber soles that protect them in case they accidentally touch live electricity. Okay, so they are insulated against electricity. Okay, so if you are going to work with electricity, you need to protect yourself. Okay. Then pilers and cutters are used to cut conducting wire. They are also used to they are also used to strip insulation from the ends of conducting wires. Then the handles are usually covered with plastic or rubber. So that is insulating material so that the electricity that might be in conducting wires may not flow to their hands, right? So here we have an example, and we have an electrician here who is wearing gloves made out of the insulating material that is protecting them. Okay, so pliers, guys, I don't know if you can see here, right? If you can just zoom in if you can at this part here, right? You can see that this end of the wire, right? We have the conducting wire, which is exposed and it's not covered with insulation. So that is where the pliers were used to cut off that insulating material, right? Okay, I think I moved on too fast now. All right, so a minute or two, then we can move on to the summary and then close off the lesson. So guys, do you have any questions with regards to the test? Do you have any questions with regards to the test that you're supposed to be writing today after school? Just another important thing, just write your names, the names that you guys also use in the Zoom class. Just also write those names on the question paper or your answer sheet. Okay. I also need you guys to write the names that you use on the class or rather in class on your papers. Guys, it is very important for you guys to email me your papers once you are done writing. Okay, I need you guys to email me your papers once you are done writing. And if you do have any questions, you can put them in the group chat so that I can quickly address them. Okay, I believe we are done. Can we move on? All right. Okay, cool. Key concepts. Some materials allow electric current to flow through them, and they are called conductors. Some materials do not allow electric current to flow through them, and these are called insulators. Metals are usually conductors, and non-metals are usually insulators. So electrical insulators have important functions like insulating wires or, excuse me, protection for electrical shock. Example is the electrician's rubber gloves. All right. Okay, so tomorrow, boom, 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 boom. Oh, sorry. Okay, so tomorrow we will be playing Kahoot, okay? But remember to download your test today. Download your test today. Once you are done writing, email it to me. And guys, you can also download the Via Africa textbook on Snaplify, and you can also download the Thunderbolts, or rather the Siavula textbook on www.thunderboltkids.co.za. So these are the textbooks that we used for this lesson, to prepare for this lesson, and you guys can get hold of them. And yes, if you do have any questions, you can email the school. The email is stemdigitalschool@africateengeeks.co.za. And my email, guys, this is the email where you'll be sending through your assignment or your test. It's onkarabetse.setso@gmail.com. Right, so my email is just appearing here, just underneath the school email. Okay. So bye guys, have a lovely day and all the best with your test. Remember, email me your test. Okay. So remember, you're writing this afternoon. Once you are done, send me an email of your answers. Okay. Goodbye guys. Enjoy the rest of your day. Have a good one. Bye guys.